Hi friends, how's it going? We're starting to do some gas laws, and so this one is Boyle's law. I don't always remember. I know I should, but I don't. Boyle's law versus Avogadro's law versus Charles's law. I just don't. So I kind of use this universal equation that we talk about sometimes, and it is this: P1 V1 over N1 T1 is going to equal P2 V2 over N2 T2. Okay, so it's just easier for me to remember this. It's a terrible circle. It's just easier for me to remember that than each of the individual laws and know when to apply them. And so, what we usually talk about when we use these simple laws are two different states. That is, I have a first state here where there's pressure and volume and the number of moles and temperature, and I have a second state right here. And I usually try to determine the two different states. For example, how does pressure change in the second state, or how does volume change in the second state, or temperature changes? What are those impacts between the first and the second state? And so if I use this simple equation right here, then I can answer almost any question that I have. For example, here I have a cylinder is filled with 10 liters of gas, and we have a piston on it. And here's an initial pressure. Okay, so we have volume and pressure, and the piston is now pushed, which is going to change the volume, compressing the gas until the gas has a final volume of 7 liters. Let's calculate the pressure. Okay, we're going to assume the number of moles are the same and the temperature is the same. Okay, so I can cross those out on either side, leaving me P1 V1 equals P2 V2, which is Boyle's law. All right, then I can just make some assignments. I have P1 equals V1 equals P2 equals V2 equals, and I can make those assignments. So the pressure in the first state is 239 kilopascal. Okay, the volume in the first one is 10 liters. The pressure in the second one is what we're trying to figure out, and the volume is 7 liters. And you see it's just some easy algebra at the moment. So now I have P2. I'm just going to solve for P2 equals P1 V1 over V2. And this, even the algebra screws up some of my friends. So be careful on that. Just be careful. It's easy. Okay, so that's going to equal 239 times 10 liters. That's kilopascal. And down here is going to be 7 liters. Okay, so let me get out my calculator here. And this is going to be 239 times 10 divided by 7 equals, and so I get a new, and I'm expecting it to increase, that new pressure P2 equals 341.428 somewhere in there. Okay, now I got to worry about those sig figs. I got 3 sig figs here, 3 and 3. So my answer is going to have 3 sig figs. And so my new pressure, P2, the answer I'm going to put into ALEKS, is 341 kilopascal. Okay, these are way doable. These Boyle's law ones are doable. I start off with this kind of universal, this composite of all of the gas laws, and I get rid of the ones that I don't need, and that way I don't have to remember what's Boyle's law, what's Charles's law, what's Avogadro's law. Although that's not hard, that's just what I do. Okay, better than AI, better than the ALEKS people usually do. This is the explanation for this type of a problem.